Hey, I just wanted to quickly plug that if you guys want any tutoring, some new slots have opened. If you look in the description, there's a link to my physics and maths tutor profile in which I do tutoring on there. So it says a curve is defined by these parametric equations x equals cos theta and y equals sine theta. Which of the following is shown below is a Cartesian equation for this curve. So I can see that there's cos theta and sine theta off the bat. Sine squared theta plus cos squared theta equals 1. So that means x squared plus y squared would equal 1. So therefore, it's that. Just remembering your identities. Whenever you see a mixture of sine and coses, you should think of all the identities and see what you can grab from them. Next, it says a periodic sequence is defined by un equals minus 1 to the power of n. State the period of the sequence and circle your answers. So remember that a periodic sequence means terms repeat in a cycle, and the number of the repeated terms is the order. So in this case, if we have un is equal to minus 1 to the n, then u1 is going to equal minus 1, u2 is going to equal, so that's what, minus 1 squared? 1, u3 is going to be minus 1, u4 is going to be 1. If you see, you skip from 1 to 3, we're skipping a term, so we're going up by 2. You can see that we repeat it again, and if we go u5 as well, it's minus 1. So every 2, you get the same result again, so its period is 2. So now it says the curve y equals log to the base 4 of x is transformed by a stretch scale factor 2 parallel to the y-axis. State the equation of the curve after it's been transformed. So whenever you have y equals f of x, right, what if you're doing any stretches in this direction, for example, if I have a point at like 0, 5, if I stretch it like here and double it, that's going to be 0 and 10. All the y coordinates get screwed up and stretched. So in this circumstance here, the question's told you it's a scale factor of 2 to the y-axis. Remember that all functions y equals something of x is telling you how to get y from x's. So if we were a scale factor of 2 parallel to the y-axis, we're stretching every single y coordinate by 2, as in timesing it by 2. So we're going to have 2y. So it's going to be 2 log to the base 4 of x here. Now, the reason it's not the other ones is because that would be halving every single y thing of y, so that'd actually a stretch fit scale factor half. Here, if we did log to the base 4 of 2x, what you're doing is, can you see how that's attached to the x's, not the y's? That's going to mess up the x's. So when you do stretches with x's like this, it would actually be stretch scale factor half into the x-axis. So you'd actually half every single x coordinate. And then here as well, that's changing the base and that's changing the graph entirely. So now it shows the graph of y equals f of x, where f of x equals ax squared plus bx plus c is shown in figure 1. And then what is it asking us to do? It is asking us to show the graph of y equals f dash of x. So they've told you that this curve is y equals ax squared plus bx plus c. However, we can see that this is a quadratic that's upside down. It's not your usual happy face parabola. So that means that this a is actually negative. So it's going to be y equals minus, well, this a is going to be some sort of negative number, right? So then if I work out the gradient, dy by dx, we're going to get 2ax plus b, right? But then the a is actually a negative value. So this is a linear curve, so it's just going to be some line. But because this is an upside down quadratic and it's negative, that a is got to be negative here. So if the a is negative, you're going to have a straight line curve going down. And so what are the options we have? So we've got, these two are out, right? So now we need to differentiate which one of these is these, right? So if you can see here that if we're looking at the curve of y equals f of x, 2ax plus b equals 0. So if we look for where y is 0, then 2ax plus b equals 0. So then that means 2ax would equal minus b. X would equal minus b over 2a. But remember that a is negative, so that would actually give you a positive x root for where y is 0. So it can't be this one because y is 0 here, but x is negative. But we just worked out that there has to be a positive value, so it's got to be this one here. Next, it says find an equation for the tangent of this curve, and it's y equals x minus 2 to the power of 4. So whenever you have a curve in the universe, because the steepness is always changing, the gradient is always changing. So that's why we do dy by dx to find the gradient function, to find out what the gradient is at any point. Whenever you have a tangent to a curve, at the exact point they're touching, the gradient of the tangent will be the same as the curve, right? So what that's trying to get you to hint at is that if you find the equation of the tangent of the curve, well, first, we're going to need to know, we're going to need to know, because it's a straight line, we need to know its gradient and we need to know some y coordinates that it sits at. So the first step is we can find out the gradient of this tangent. So that's going to be dy by dx, which is going to be 4x minus 2 to the power of 3, and then divide by the derivative, which is 1. That's fine. So that's dy by dx. Now, to find the gradient at that exact point, which will be the same as the tangent, you would just sub x equals 0 into this. And if we sub x equals 0 into that, then we get, what's that? So 4 minus 2 to the power of 3, which gives you minus 32. So now we know that the gradient of this tangent is minus 32. We know that it's at the point x is 0, so we know the x coordinate has to be 0 here. We need to find its y coordinate. Remember that this is a tangent, so we're going to be touching the curve there. So whatever the x coordinate is here of this tangent is going to be the same as the curve. So all you do is you just do y equals, so x minus 2 to the power of 4. So you're going to figure out y. All you need to do is just put 0 minus 2 to the power of 4. And if we do that, so 0 minus 2 to the power of 4, would give you 16. So now we know that this thing lies at 0 and 16. To find any equation of a straight line, you need to use y equals y1 equals m x minus x1. No excuses. I could see all these other weird techniques. None of it is allowed. This is the only way. So it would be y minus ry1, 16, equals m, which is minus 32, x minus 0. So that means that y minus 16 equals minus 32x. And is there any specific form they want in? No, I'll just put it as y equals minus 32x plus 16. Done and dusted. So here it says, find the first two terms in ascending powers of x, the binomial expansion of 1 minus x over 2 to the half. Now in this circumstance, you can't use your nice NCR one because it's not a positive whole integer. Here, what we have is we've got a fraction. So if that's the case, then we're going to have to use that funky formula in the formula book. So if I find that, one sec. So here we're going to have to use this 1 plus x to the n, where n is less than is not a whole number, so it's going to be this. So it's going to be, they only want the first two terms, so it's going to be 1 plus nx, so it's going to be 1 plus, and then n is, well, you can see it's n here, and that's a half, so that's a half. And then it's going to be, well, you can see that's x, and it's nx, but this x has been replaced with this whole thing here, 1 plus x, 1 minus x over 2. So take it at very face value, what it means is that x has literally just been replaced with minus x over 2. So if we do that, x over 2, it would just be 1 minus 1 over 4x. Now it says, hence for small values of x, show that sine 4x plus the root of cos x roughly equals a plus bx plus cx squared. What it's alluding to is that the small angle formulas are going to be playing a role, so if you have small values of x here, right? So sine theta roughly equals theta, cos theta roughly equals 1 minus theta squared over 2. So in this case, sine 4x, can you see how that sine theta is roughly theta? That means that sine 4x, or 4 theta, is going to be 4 theta. So that means 4x plus, and then the square root of cos x. So if this is cos x, cos theta, that's going to be 1 minus the x squared over 2. We need to replace that to cos x. So it's going to be the square root of 1 minus x squared over 2. Wait, I don't know why that made this bracket so big. Whoops. 1 minus x squared over 2 roughly equals a plus bx plus cx squared. So it says hence. So hence usually hints at the fact you've got to use the bit before from the previous question. Well, if we look, they've told us to find the expansion of 1 minus x over 2 to the half. So we can, if I rewrite this, it'll be 4x plus 1 minus x squared over 2 to the half. If you can, it says hence, so usually that hints at something. I'm looking at the previous part of the question. If you look at the previous part, we've got this 1 minus x over 2 to the half gives you this. Now, can you see how they are essentially identical? The only difference is that now I've got an x squared instead of an x. So this means you can take that expansion and just put it here in place of this. They change the x to an x squared, because between the two of these, the only thing that's changed is that has become an x squared. So in that case, we now have 4x plus, and then it would be 1 minus 1 over 4x squared. So if we tidy this up, then it would be minus a quarter x squared plus 4. Well, actually, no, they want it in this form, sorry. So it's going to be 1 plus 4x minus 1 over 4x squared. And that's how you do it. So now it says, draw the graph of y equals cot x minus pi over half. So cot x, remember, is 1 over tan x. So cot x is undefined when tan x, tan x, equals 0. Whoops. So that means whenever tan x is 0, so if we do it in radians, when you do it in radians, cot x will have asymptotes where you have multiples of pi normally. Because if we look at, for example, tan graphs, if you were to do tan pi, that's 0. If you were to do tan 2 pi, that's 0. Tan 3 pi, 0. 4 pi, and so forth. So every 180 degrees, you get an asymptote, or every pi, right? So here, whenever tan is 0, in the cot graph, whenever you have a multiple of pi, you're going to have an asymptote. The thing is here, though, is that we've got y equals cot x minus pi over 2. So what that means is we've translated this whole graph, because that would be y equals cot x, we've translated it by a vector of pi over 2, 0. So with your tan graphs, remember that you have zeros at every multiple of pi, and it shoots off to asymptotes whenever you've got pi over 2, right? Because it'd be another 0. So your tan graph kind of looks like that with these are halves. I just said that when you've got cot graphs, it becomes undefined when tan equals 0. So cot graph, so whenever it's 0, your cot graph is actually shooting off to, at that point when this tan is 0, remember, like from here, the cot is shooting off to infinity. However, we've translated this graph by a vector pi over 2, 0. So every single x coordinate has been shifted to the right by pi over 2. So instead of having an asymptote where, for example, here, an asymptote is 0, it's now going an asymptote of pi over 2. So what we're going to do is I'm going to add pi over 2, and we're going to go up in our pi's of 2. So 3 pi over 2. So now what we got to do is just sketch it in the same sense. So remember that, like, now it's not going to asymptote at the 0, it's going to asymptote every, like, half pi instead. This is now going to become its new 0, a cot graph, because it's been translated. So it's going to be something like, this is going to be so hard to draw. Let me zoom out and do this a bit better. So it's going to be, it's really badly drawn, but it's going to like asymptote like this. And then at the 3 pi over 2, the next one's going to roll in and it's going to do the same thing like that. But it's only asking it for up to 2 pi, so it would just be like this. Oh my god. It's just asymptoting there. That's what it's trying to recognize. Why? There. Right, so the lines L1 and L2 are parallel. L1 has that equation, L2 has that equation. L1 intersects the y-axis at the point P, which they've labeled, and the Q is the point on the line L closest to P as shown in this diagram. So it says find the coordinates of Q. Okay, right, so first off the bat, what I'm going to do is I'm going to find out what the coordinates of P are. So with L1, we know that 5x plus 3y equals 15. So 3y would equal 15 minus 5x. So y equals, what's that? 5 minus 5 over 3x. So if I put that to be 0, then that means the coordinate here of y is going to be 0. So that if I put 0 there, that's going to be 5. So it's 0, 5 here at P. We've got that part. So what I can do now is we know the equation of line 1. I can find the line of this equation of this normal here, this perpendicular line connecting the two. And then they've told us the line 2 equation. So the perpendicular line here is going to intersect with that, and they'll have the same y coordinate and x coordinate at that point. So I'm going to do that. So what I'm going to do is now I'm going to look for that equation. So before I've already written L as y equals 5 minus 5 over 3x. So therefore, the gradient of the normal is going to be the inverse of this. It's a negative inverse. It's going to be 3/5. And I know that now we have these coordinates of 0 and 5. So y minus y1 equals mx minus x1. So y minus 5 equals 3/5 x minus 0. So that means that if I make this look a bit nicer, we'll say that y minus 5 equals 3/5 x. So y equals 3/5 x plus 5. So that is the equation of the normal. Now you can see that this normal intersects Q, so that means at the same point, they'll have the same coordinates there at that intersection. So for line L2, which is Q's line, 5x plus 3y equals 83. So 3y equals 83 minus 5x. 3y equals 83 minus 5x. So y equals 83 over 3 minus 5 over 3x. Because they intersect, we're going to make those two equal each other. So that means that 3 over 5x plus 5 equals 83 over 3 minus 5 over 3x. So if I now try to tidy this up, 3/5 plus 5 over 3 is what? So that's 34 over 15x equals, and it's going to be 83 over 3 minus 5, which is what? 68 over 3. If I then divide both sides by 34 over 15, I should hopefully tidy that up, and that'll give you x equals 10. So then we know what the x coordinate of Q is. We know that's 10. We need to find its y. So all you got to do is slap it back into the equation for Q, which I've rewritten as this. So that means that when x is 10, y would equal just 83 over 3 with 83 over 3 minus 5 over 3 times 10, which gives you 11. So now I know the coordinates of this is 10 and 11. So now it says, hence show that PQ is k root 34, where k is an integer to be found. So the distance between two lines, remember, is the square root of y2 minus y1 all squared plus x2 minus x1 all squared. So in this case, it's going to be the square root of the second y coordinate, so 11 minus 5 all squared plus 10 minus 0 all squared, which is going to equal, so 11 minus 5 all squared gives us the square root of 36 plus 100, which is the square root of 136, which gives you, if you simplify that down, that gives you 2 root 34. So therefore, your k is 2. So now it says a circle C has the center A17 and L1 and L2 are both tangents to C, so it says find A. Okay, so we know that, just from before, we know that P lies at 0, 5, and then Q lies at 10, 11. And they've told us that if we just look back at that diagram, these are tangents to a circle now. So we don't know which parts of the circle they're touching. So it could be here and here, whatever, right? So it could be there and there, something like that. So what we can do is we can find the equation of the line between them, and then we can find the normal to that. Because the reason that helps is because here, for example, in here, they're not going to go straight through the center, and that's a really bad drawing, but they won't. However, if I find the equation of the line that passes through the midpoint of them, that line will eventually hit the center. So what I'm going to do is I'm going to find the midpoint of these two lines first. So the midpoint is just going to be your x1 plus x2 divided by 2, and then your y1, y plus y2 over 2. So if I do that, that's going to be 0 plus 10 over 2, which is 5, and then it's going to be what? 5 plus 11 over 2, 16 over 2, so that's going to be 8. So we know that this midpoint of these two lines here is going to be 5, 8. Cool. Now, we know that the gradient of that normal from before when I did my working out was, well, we know the gradient of each of these lines is minus 5 over 3. So the gradient of this would have been 3/5, but now we're going back down again, so it's going to be minus 5 over 3. Okay, so I'm going to just tidy this up to make it look a little bit nicer. So 3y minus, what's 8 times 3? 8, 60, 24, equals minus 5x plus 25. So then 3y equals minus 5x plus 49. Now they've told you that this passes, well, not they've told you, so they told you that this center has a circle, the circle has a center a minus 17. This line that we just worked out will go straight through the center, so that means that the y here has to, this has to come out from this equation. So if 3y equals all of this, blah, 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 then this 3 times this should, in theory, equal this whole thing. So if I do 3 times minus 17, that's minus 51. So minus 51 should equal minus 5x plus 49 if it sits on that curve. And that x will tell us, the x coordinate that makes minus 17. So then minus 51 minus 49 is minus 100. So minus 100 equals minus 5x, so x would equal 20, which is the a coordinate, so a is 20. Done. Now it says we need to find the equation of c. So we at least know straight off the bat, well, a was 20, so it's going to be x minus 20 squared plus, and then they told us the other center coordinate was minus 17, so it's going to be y plus 17 all squared equals r squared. Now we need to figure out what the radius is, the r. So in this question, they've told us we have two parallel tangents to the circle. So no matter where they are, there are two parallel lines and their tangents, which means that, like, wherever they intersect is going to be the distance between the two is going to be the diameter. So we worked out the distance between the two to be 2 root 34, which is its diameter. So its radius is going to be root 34. So its radius squared is going to be 34. So that means x minus 20 squared plus y plus 17 squared equals 34. Done. So now it says the first three terms of an arithmetic sequence are given by this: 2x plus 5, 5x plus 1, 6x plus 7. So show that x equals 5 is the only one that gives you an arithmetic sequence. So in this circumstance, the u1, the first term would be 2x plus 5, u2 would be 5x plus 1, and then u3 equals 6x plus 7. Now when you've got a arithmetic sequence, each time you're going to be adding a common difference, d, right? So that must mean that u2 minus u1 must equal u3 minus u2, the difference between these two, right? So u2 minus u1 is what? 5x plus 1 minus 2x plus 5 has to be equal to 3 minus 2, so 6x plus 7 minus 5x plus 1. So if I tidy that up, I get 5x plus 1 minus 2x minus 5 equals 6x plus 7 minus 5x minus 1. So if I then tidy this up a little bit more, so 5 minus 2, well, that's 3x. 1 minus 5 is minus 4 equals 6 minus 5. So x, 7 minus 1 plus 6. So if I move that across, I'll get 2x. No, sorry. If I do that, I get 2x equals 6 plus 10, so x equals 5. So that's the only way you can have it. That's the only solution there. So then it says write down the value of the first term of the sequence. So x is 5 is the only one that gives you that. So 2 times 5 plus 5 is 15. So the first value is 15. Then it says find the value of the common difference of the sequence. So the first, if I just look back at that sequence, the very first thing is what? 2x plus 5. If I substitute 5 in, I get that. And then the next one, if I substitute 5 in, I get 5 plus 1, which is what? 26. 5 times 5 plus 1, sorry. And the next one is 6 times 5 plus 1, which is 31. Each time I'm adding 11, so the common difference is 11. So it says the sum of the first n terms of this arithmetic sequence is Sn, where Sn is less than 100,000, but Sn plus 1 is greater than 100,000. Find the value of n. So in this arithmetic progression, we know that the first term is, oh my god, I've forgotten it already, and I just wrote it, 15, and d is going to be 11. So the sum of any n terms is going to be n over 2, 2a plus, and then n minus 1d. So in this circumstance, n over 2, 2a, well, that's 30, plus n minus 1d, so 11, and we don't know what the n is, n minus 1, is less than 100,000. So that means that n 30 plus 11, n minus 1, is less than 200,000. So then if I expand the bracket, 30n plus 11n, n minus 1 is less than 200,000. If I then expand again, 30n plus 11n squared minus 11 is less or equal to 200,000. If I then tidy this up, I get what? 11n squared. 30 minus 11 is what? 19. So what? 11n squared plus 19n minus 200,000 is less than 0. So if I find the critical values of this quadratic, we get 11, 9, oops. If I do that, we get 11, 19 minus 200,000. So we get two critical values of 133.979, or it could be minus 135. Well, you can't really have a negative at the end term. So it's not really reached the 134th term, so that n has got to be 133. So then if I do sum of n plus 1, it should be above that, which it would be, because if this exactly would give me something that's less than 200,000, so if I then went one up to 134, it would give me something that's above 100,000 or the 200,000. So there you go, that's how you do that. The diagram shows a sector of a circle OAB. So OAB is the sector, and they've got a triangle, and it says the point C lies on OB such that AC is perpendicular to OB. So AC is perpendicular to OB. Nice. I'm going to just put that there so I remember. Angle AOB is theta radians. Given the area of the triangle OAC is half the area of the sector OAB, show that theta equals sine 2 theta. So the area of a sector is going to equal a half r squared theta. So we know that an area of a triangle is a half AB sine theta, right, or sine C, but they've told us that this is a right angled triangle. So we can do a bit of mucking about here and figure out what's going on. We know that this has to be the radius, that's going to be r, and we've got a little triangle here that's right angled with an r here and an angle theta here, and that's our opposite, that's our adjacent. So we can use so, which is sine theta equals the opposite over the adjacent. So, sorry, no, opposite of the hypotenuse, sorry. So the opposite is going to be r sine theta. So this distance here has to be r sine theta from A to C. And then we know that we can use the adjacent and the hypotenuse cos, so we're going to get cos theta equals the adjacent over hypotenuse, which is r. So r cos theta equals the adjacent. So that means that this is r cos theta. Now the area of a right angled triangle is going to be just a half times AB. So it's going to be a half times r cos theta times r sine theta, which is going to be a half r squared sine theta cos theta. They've told us in the question that the area of the triangle is half that of the sector, so that means that a half r squared sine theta cos theta equals a half times this. It's going to be a quarter r squared theta. So then we can do is we can cancel these out, and we're left with a half sine theta cos theta equals a quarter theta. Then I could go forward and say, well, if I times everything by 4, I'll get 2 sine theta cos theta equals theta. You should be able to recognize now that that is sine 2a. So sine 2 theta, sine 2 theta, must equal theta from that alone. So now it says, use a suitable change of sign to show that a solution of the equation lies in this interval here. So fine, theta equals sine 2 theta. So what I'm going to say is that I'm going to let this equal 0. So I'm going to say that theta minus sine 2 theta equals 0. And if I say that f of theta is going to be theta minus sine 2 theta, all I've got to do is plug these numbers in and see if we get a change of sign. So if I do the f, if I put pi over 5 into this equation, so pi over 5, give me a minute. So pi over 5 is going to be this minus sine 2 of that. It gives us minus 0.32274, which is less than 0. So then if I now do f of 2 pi over 5, that gives us 0.66885, which is greater than 0. Therefore, the solution, because there's a change of sign, the solution lies between, and then these, I can't be bothered right now, but there you go. The Newton-Raphson method is used to find an approximate solution to the equation here. Using theta 1 is pi over 5 is the first approximation for theta. Apply the Newton-Raphson method to find the value of theta 3 and give your answer to 3 decimal places. The Newton-Raphson formula says xn plus 1 equals xn minus f of x n over f dash xn. So we know that f of x, from what we said before, is going to be theta minus sine 2 theta, or I should say f of theta. So if we differentiate so f of theta, then we're going to have 1 minus 2 cos 2 theta, because we're going to differentiate it. So if you differentiate sine, it becomes cos, but you have to times by the derivative of that as well. So then what we're going to end up with is we're going to have theta n plus 1 equals the previous theta value minus theta minus sine 2 theta over 1 minus 2 cos 2 theta. So you just look at the formula and you just put the bits in, right? So they've told you what, that the first value is pi over 5. All you do is you just stick that in and then keep hitting answer until you get what you need. So make sure you're in radians. If I put pi over 5 into this, it will be pi over 5 minus, then it would be pi over 5 minus sine 2 pi over 5 over 1 minus 2 cos 2 pi over 5. So the first if I do that, then theta 1 is that, theta 2 is roughly 1.473226. Then theta 3 is roughly 1.0413, blah, blah. It's going to be 1.041. There. So now it says, explain how a more accurate approximation for theta can be found using the Newton-Raphson method. So, I mean, we've only done it a couple times. You can just keep doing it. So we could use more iterations. Use more iterations. And eventually, when you can see it's going down and down and down, it might just get closer and closer to a specific value. There. So now it says, explain why using theta 1 as pi over 6 in this Newton-Raphson method wouldn't give us a solution to theta. Well, from before, I've just crossed it out, but the function would have had, oh my god, what was it? Theta minus sine 2 theta, so theta and minus that over 1 minus 2 cos 2 theta. If you were to do 1 minus 2 cos 2 theta, and you were to do theta over 6 into that, theta over 6 into 1 minus 2 cos 2 theta, it equals 0. And that's undefined. So therefore, that's why you can't do it. Okay, so now it says the polynomial is this, whatever b is a constant. Use the factor theorem to show that x plus 2 is a factor of px for all of that. So what that means is x plus 2, if that's a factor, then that has to equal 0. So that means that x has got to be minus 2. So what you can do is you can sub in. So then we would want p of minus 2. So that's going to be minus 2 cubed, which is what, minus 8, plus, and then it's going to be b plus 2. So it's going to be minus 2 times minus 2 is 4. So 4b plus 2 plus, and then it's going to be, minus 2b plus 2 plus 8, right? And that has to equal 0 if this is a factor. So if that's the case, let's tidy some of this up. So 4b plus 2 minus 2b plus 2 must equal 0. So then if I divide everything by 2, b plus 2 minus b plus 2 equals 0. So can you see how that's 0 no matter what? So no matter what b is in the universe, it could be like 9 million, and that could be 9 million, it's always 0. So therefore, that has to be a factor. Now it says the graph of y equals px meets the x-axis exactly 2 points. Sketch a possible graph of y equals px. So first off, they've told us that x plus 2 is a factor, so that means one of the roots of it is minus 2. So that means that if I put minus 2 into this, I get 0 out, which means that if I put minus 2 into this, the y coordinate would be 0. So we've at least got 1 there. Now we need to find the bit where it intercepts the y-axis. So that means it's when x is 0. So if we have this function here, p of x, we do p of 0, then it's going to be 0 cubed plus, well, that becomes 0, and that becomes 0 and 8. So that means that the other part where it intersects the y-axis here has got to be 0, 8. Now, the highest power this has is 3, so it's a cubic graph, and it's a positive x cubed, so it's going to look something like that. Whoops, like this. So we need to just figure out how to link them together. Now it tells us it meets the x-axis at only 2 points. First off, I can say that it's probably going to do something, it's going to do something like this, right? And then it's going to go down. Now, if it went back down beneath the axis again, that's 1, 2, 3 points, so that's not possible. So in that case, the only thing that is possible is it would do something like this, where that's the second point it meets the x-axis. So it says, given that p of x can be written by this, x plus 2 and x squared plus bx plus 4, find the value of h. So in this question, they've told us that it crosses the x-axis, it meets the x-axis at exactly 2 points. So the roots of it are going to be here, and there's going to be something else here, but it doesn't go past that axis. So that means that this thing has two values for when it is 0. So that could be that this is -2, or this whole thing could make something that makes this eventually become 0. So that means that the discriminant of this means it only has one real root. It can only be one value. So what we can say is that b squared minus 4ac equals 0. And if we just list out what we've got, so a is 1, b is b, and then c is 4. So that means that b squared minus 4, 1 times 4 equals 0. So b squared minus 16 equals 0. So b squared equals 16. So that means that b must equal plus or minus 4. We need to figure out which one of these would make it work, because in which one would fit. So then if b was my plus 4, for example, it'd be x squared plus 2x, sorry, plus 4x, whoops, plus 4. Or it could be x squared minus 4x plus 4. So the roots of this would be x equals, sorry, well, if we were to find the roots of this, then it would be x equals minus 2, right? Then if we did it for the other one, so plus 2. Now, it can't be this one because we already have that root here. If we had b to be plus 4, it would give us x equals minus 2 for the root when we do that. Therefore, b cannot equal plus 4 because this gives one root for p of x, and that would give the root of plus 2. Sorry, minus 2. Whoops. So, therefore, your b has to be minus 4. A geometric sequence has the first term 1 and a common ratio of a half. Find the sum to infinity of the sequence, or the sum to infinity equals a over 1 minus r, which is going to be 1 over 1 minus a half, which is just 2. So now it says, hence or otherwise evaluate the sine 30 to the power of n is 1 all the way to infinity. So it's the sum to infinity of this function here then. So it's the asking for the sum to infinity of this thing here. So first of all, we need to figure out what our first term is. So the first term is going to be sine 30, which is a half. So then a has to be a half. Now it's squaring this value. It's a half squared every time. So if it's a half squared, then that means we're timesing this thing, and cubed and so forth, where each one is going to be timesing it by a half. So that means a equals a half, but also r must equal a half as well. So it's asking for the sum to infinity, so it's just going to be a over 1 minus r, which is going to be a half over 1 minus a half, which is just 1. So now it says find the smallest positive exact value of theta in radians which satisfies this equation. So make sure you calculate this in radians mode in case we need to use that. So it's saying that we're working out the sum to infinity of cos theta to the power of n, where n starts at 0. And it's asking us to see at what point this equals 2 minus root 2. So first of all, we need to figure out what our sum to infinity equation actually is going to be. So remember that the sum to infinity, whoops, is going to equal a over 1 minus r. We need our a and we need our r. We need to figure out what our a is. Well, they've told us it's cos theta to the power of n. Regardless of the fact we don't know what theta is, anything to the power of 0 is 1. So that means our a is 1, and each time you're going to be timesing it by cos theta, so squaring, and so forth. Squaring, cubing, etc., whatever. Every time it's going to be times the cos theta. So that means our r is cos theta. So our sum to infinity is going to be 1 over 1 minus cos theta. And they've told us that that equals 2 minus root 2. So now we can tidy this up a little bit and say, well, okay, 1 equals 2 minus root 2, 1 minus cos theta. So 1 equals, what's that? 2 minus 2 cos theta minus root 2 plus root 2 cos theta. So if I just collect all the like terms up, so 1 minus 2 plus root 2. So 1 minus 2 plus root 2 gives us minus 1 plus root 2 equals, and then what's that? Minus 2 plus root 2, which equals minus 2 plus root 2 cos theta. So then cos theta equals minus 1 plus root 2, all divided by minus 2 plus root 2, which is minus 1 plus root 2 over minus 2 plus root 2, which is just minus root 2 over 2. Now, we need to figure out what the theta is. So theta would be cos to minus 1 of the answer, which is 3 pi over 4. So figure 2 shows the approximate shape of a vertical cross-section in the entrance to a cave, and it has a horizontal floor. The entrance to the cave joins the floor at the points O and P. So Gary models the shape of this cross-section of the entrance using this equation, x squared plus y squared equals a root x minus y, where a is a constant and x and y the horizontal and vertical distances respectively in meters measured from O. The distance OP is 16 meters. Find the value of a that Gary should use in the model. There's no way in hell somebody's called Gary in this question, bro. So in the question, it tells us that x is the horizontal and y is the vertical distances. So that means across from O to P, we're not actually crossing any vertical distance, it's just horizontal. We can sub in x equals 16 and y equals 0. So if we do that, we get 16 squared plus 0 squared equals a root 16 minus y. So then 16 squared is 256 equals a root 16, sorry, minus 0. So then 256 divided by root 16 is 64, so a equals 64, sorry. So now it says, show that the maximum height of the cave of OP is approximately 10 plus 5 meters. So whenever we're looking at maximum or minimum things to do with functions, we're looking for the turning point. Because whenever you have the maximum of a function or a curve, at the highest point, the gradient will be 0 because it's changing directions. And the same goes for the lowest point. So because they've modeled it with a function, we're going to have to differentiate the function. Now the other thing is because that there is like mixtures of x's and y's in it, we're going to have to use implicit differentiation. So I'm going to just rewrite this now here. So x squared plus y squared equals, what was 8? Oh, 64 root x. So I'm going to rewrite that as 64x to the half minus y. So it's the same as differentiating normally. All you do is you just stick a dy by dx in every single differentiation that you do on a y. So for example here, it would be 2x plus 2y and then dy by dx equals, so a half is 32x to the minus a half minus 1 dy by dx. Then all you do is you collect all your like terms. So that's going to be, if I move this across to this side, we'll get 2y dy by dx plus dy by dx equals 32x to the minus a half minus 2x. Then if I factorize, I can take that dy by dx out. So dy by dx, 2y plus 1 equals 32x to the minus a half minus 2x. So then dy by dx equals 32x to the minus a half minus 2x over 2y plus 1, right? And they've told us that we want to look for the maximum height. So this is the gradient function of a curve. Remember that any maximum at that point is going to have a gradient of 0. So what we can do is we can make that equal 0. And it doesn't matter what the bottom is, because if you times both sides by 2y plus 1, it'll still just stay as, that becomes 0. So that means that 32x to the minus a half minus 2x equals 0. So if I just tidy this back up a little bit, so we've got 32 over root x equals 2x. So if I times both sides by root x, then I'll get 32 equals 2x to the, so times get both by root x, it's going to be 1 plus, it's supposed to be 3 over 2. So x to the power of 3 over 2 equals 16, so x must equal the cube root of that squared. So that would be 16 to the 2/3, which is roughly 6.3496, blah, 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 right? So then, this is the x value that would tell us that dy by dx is 0. So all we need to do is plug it back in to get y. So if we find the original equation again, it was what? X squared plus y squared equals 64 root x minus y. All you do is you sub this value in. So we're going to get 6.3496 squared plus y squared equals 64 root 6.3496. What's that again? Sorry. Minus y. So if I move it here, that's going to give us what? Like 40.317 plus y squared equals, and then 64 root of that is going to give us 161.27 minus y. So then y squared plus y, what's that? 40.317 minus 161.27 minus 120.953 equals 0. So then if I just use my calculator to work out the roots of that, it gives us y equals 10.509, or it's minus 11. Well, it can't be that, so there you go. That's how you prove it. So now it says, suggest one limitation of the model Gary has used. So remember that Gary's assuming that this is just a curve that will fit this perfectly. In real life, there's probably going to be like bits and bobs and sticky outy bits and stuff. So you could say something like the entrance isn't smooth. So it says the region bounded by this curve, y equals 2x minus 8 times ln x is this area below, blah, blah, blah. So it says use the trapezium rule of 5 ordinates to estimate an area of the shaded region. So they've told us that this is 5 ordinates, which means it's a fancy way of saying there's sort of y values. But remember, the y values are shared between two strips. So what we need, so the number of ordinates is going to be n plus 1, and that's told you it's 5. But the number of strips is different to the number of ordinates, because the number of ordinates means verticals. So that means that n is actually 4. So n is, the number of strips is 4, our bounds are 1 to 4, so our width is going to be 4 minus 1 over 4. If we do that, we get 0.75. So now what you do is you make a little table of x and y's, and we start at 1, so that's 1, and then we've got 1.75, 1, and then we get what? 2.5, then we get 3.25, and then we get 4. And then we need to work out our y values for each of these as well. So all you do is you just slap them into the equation and see what we get out. So then it's going to be, the next one is going to be minus 2.51827, and then it's going to be minus 2.74887. So I've written this table horribly. And then it's going to be minus 1.76798, and then that's going to be 0. So then the actual formula for the trapezium rule is just going to be h over 2, y0 plus 2 lots of every single one in between, plus y and the last strip. So it's going to be h over 2, 0 plus 2 lots of minus 2.51827 minus 2.474887 minus 1.76798 plus 0. When the h over 2, the h in this case is what? Sorry, 0.75. If we do that, we should get 0.75 over 2, 0 plus 2 lots of minus 2.51827 minus 2.74887 minus 1.76. We should get an answer of roughly minus 5.2767, which is roughly, because it's just wanting an answer of it just wants the actual area. So we're not going to keep it as minuses. So it's going to be 5.28. We don't really want to have it as a negative. It just wants the area of the shaded region. So now it says, show that the exact area is given by these two things and then fully justify your answer. So here, if it wants the exact area, we're going to have to do some integrating. So what we need to do is we've got to go from 1 to 4, and we're going to integrate 2x minus 8 ln x dx. Now that should be uv. Now we need to figure out, we're going to do integration by parts. So we need to set u to be something and then v to be something else. So okay, so we're going to integrate by parts. So u, I'm going to set as ln x. Remember that the other one is dv over du. So dv over dx, which is going to be 2x minus 8. So then du over dx is going to equal 1 over x. And then v is going to be this integrated, which is going to be what? 2x squared over 2. So 2 over 2x squared, so that's just going to be x squared minus 8x. Cool. So then we remember that the integral is uv minus the integral vd over dx. So I'm going to work out what uv is. uv is going to be x squared ln x minus 8x ln x, and then v du over dx equals, well, it's just this whole thing divided by that, so it's going to be x minus 8. So the integral of v du over dx with respect to x is going to equal x squared over 2 minus 8x. So our overall integral is going to be uv minus the integral v du over dx. So that's going to equal uv wherever it's gone, so x squared ln x minus 8x ln x, and then minus the integral of v du over dx is going to be minus, where's it gone? Oh, yeah, x plus 8. So if I just tidy this up a bit, I'll get ln x squared minus 8 minus x plus 8. Cool, and they want us to do it from 4 to 1. So if I put the numbers in, we're going to get ln 4 times 4 squared minus 8, which is just going to be minus 4 plus 8. That's going to be minus everything in this bracket. So it's going to be ln 1, and then 1 squared minus 8, minus 1 plus 8. Cool, so now if we try and tidy this up, we get, so it's 8 ln 4 minus 4 plus 8 plus 4 minus, and then it's going to be, well, remember that ln 1 is 0. It'd be minus 1 plus 8. So minus 1 plus 8 is plus 7, so it's going to be minus 7. Cool. So then 4 minus 7 is minus 3. It's going to be 8 ln 4 minus 3, right? But they want it in what form? They want it in the form 32 ln 2 minus 33 over 2. So then that means our integral is going to be, I'm going to tidy this up and factorize it. I'm going to say that's ln x squared minus 8x. So it's going to be minus this whole thing. So it's going to be minus a half x squared plus 8x. And they want us to do that from 4 and 1. So then our first one is going to be ln 4. And then what's that? 4 squared minus 8 times 4. So it's going to be minus 16 minus a half 4 squared, so minus 8 plus 8 times 4, 32. And it's going to be minus, and then ln 1, and then 1 squared minus 8, minus a half times 1 squared, minus a half plus 8. So if I try and tidy this up now, well, it's going to be minus 16 ln 4, 32 minus 8, plus 24 minus, well, that becomes 0. So minus a half plus 8 is, what's that going to be? That's going to be minus 15 over 2. So it's going to be, sorry, plus 15 over 2, so it's going to be minus 15 over 2. So we get minus 16 ln 4, and then that's going to be what? 24 minus 15, so it's going to be plus 33 over 2. Now, you should ideally try and get this down as low as possible powers-wise. You should be able to recognize that's ln2, that's the same as saying 2 squared, and also in the question it tells you 32 ln2. So I'm going to change that to minus 16 ln. Well, that you can rewrite that as 2 squared plus 33 over 2. Remember that you could, if it's a power in here, you can times that by that. So it's going to be minus 32 ln 2 plus 33 over 2. And then just to make it look nicer, I put the positive at the start. So 33 over 2 minus 32 ln 2. We're almost done, but you should be able to recognize that this is under the x-axis. So then the area is actually negative. So shaded area negative. Therefore, it's actually the opposite of this. It's going to be 32 ln 2 minus 33 over 2. And there you go. That's how you do it. Just don't forget that when you have like an area under the x-axis is negative, so the area is actually a negative value. Okay, so now it says, given that y equals cosec theta, express y in terms of sine theta. So cosec means 1 over sine theta, so y just equals 1 over sine theta. Or you could say it's y equals sine theta all to the minus 1. Now it says, hence prove that dy by d theta equals minus negative cosec cot theta. Fine. So if we're going to do it this way, let's have a look what we have. So dy by d theta. So if y equals sine theta to the minus 1, so if y equals sine to the minus theta 1, well, sine theta to the minus 1, dy by d theta is going to equal minus 1 times the derivative of what's in the bracket in terms of theta. So sine differentiates into cos. So it's going to be times cos theta. And then it's going to be the whole of this, again, but with the power taken down by 1. So sine theta minus 2. Alternatively, you could do the chain rule as well, but this is just a shortcut, which gives you minus cos theta over sine squared theta, like so. Fine. So we're in a bit of a pickle, because we can see that we've got a minus cos theta and a sine squared theta. So if we look at this here, it's saying it's equal to minus cosec theta cot theta, which is the same as saying, well, minus 1 over sine theta times cos theta over sine theta. Because remember that tan theta equals sine theta over cos theta. So then cot would be 1 over that. So we can see that we've got the cos at the top, the negative cos, which is here, but we've got sine times sine. So I can split this out into negative cos theta over sine theta times 1 over sine theta, which you can see becomes negative cot theta times cosec theta, which is this, well, which is exactly that. So it's just negative cosec theta cot theta. There you go. So now it says, show that the square root of y squared minus 1 over y equals cos theta for those values of theta. So in the question, it's told us that y equals cosec theta, so a good start is to put the cosec theta in there. So that's going to be, what, cosec squared theta minus 1, the square root of this whole thing, cosec theta. Now we need to think of our other identities that we know. Well, one of the identities we have is that cosec squared theta equals 1 plus cot squared theta. So if that becomes 1 plus cot squared theta minus 1, then what we end up with is the square root of cot squared theta over cosec theta, which is then cot theta over cosec theta. Now, what else can we try and do here? So, well, cot theta is going to be equal to cos theta over sine theta. So that's going to turn into cos theta over sine theta cosec theta. Remember that cosec theta is 1 over sine theta, so that's actually going to become cos theta, and remember that we're timesing it by 1 over sine theta, divided by 1 over sine theta. It's the same as timesing it by the inverse. So it's going to be sine theta over sine theta, which cancels out, and you're left with cos theta. There you go. So now it says, show that 1 over x squared root x squared minus 4 equals, when you integrate it, x squared minus 4 over 4x plus c. Fine. So in the previous question, we established that you could use x equals 2 cosec u for this, and you would get k sine u, k times the integral of sine u du, right? This is the same thing here. So that means that this integral is going to equal minus a quarter times the integral of sine u du, which if we do that, sine integrates to minus cos, because remember, sine, cos, negative sine. So if we go sine to cos, because that's differentiating, then it's going to go up that way. So it's going to become minus 4, 1 over 4, times minus cos, which means your integral then becomes 1 over 4 cos u plus c. Now the problem is that that's not very useful because this is all in terms of x's. So we originally said that x equals 2 cosec u. Well, let's say that that's going to be x over 2 would be cosec u, right? Now that's the same as saying 1 over sine. So then I could say that's the same as saying x equals 2 over sine u. So we know that in this scenario, sine u would equal, so if I bring that up there, then that would be 2 over x, right? So again, we've got 1 over 4 cos u plus c. That's our integral, which is 1 over 4 cos u plus c. So if I just focus in on the cos u, we could remember that cos squared u would equal 1 minus sine squared u. So cos u would equal the square root of 1 minus sine squared u. So that's that and that's that. Then I can then go ahead and say, well, that's going to be a quarter 1 minus sine squared u plus c. That's our integral. And then we've just established that sine u is that, so then sine squared u would equal 4 over x. So then that means our integral now becomes 1 over 4, 1 minus 4 over x squared. Unfortunately, we're still not done because you can see there's a whole load of x squareds, minus 4s, and all of this stuff, right? So if I then take a look at this fraction in further detail, 1 minus 4 over x squared, right, that's the same as saying something like 1 over 1 minus 4 over x squared. So because that's an x squared, what I can do is I can turn this into x squared over x squared minus 4 over x squared, because that's still 1, and that might get us somewhere, right? So then I could say this is the same as saying x squared minus 4 over x squared. So it's like almost putting that fraction back into here. So now I can go ahead and say, well, the integral of this whole thing is 1 over 4, what's that, the square root of x squared minus 4 over x squared. So our integral then equals 1 over 4, and I'm going to rewrite this now, split it down a bit more to x squared minus 4 over the square root of x squared. This works because, for example, if you had root 4 times root 3, you can say that's root 12. If I had root 4 times, I don't know, root 1/5, then you could say that's root 4 over 5. So in this circumstance, now we have the integral equals a quarter times the square root of x squared minus 4 over x, and then you can see the integral becomes the square root of x squared minus 4 over 4x, like so. And there you go. That's that done and dusted. Thank you so much. Please like, share, and subscribe. Sorry, this last question, I sound really dead. I'm sick. But thank you.